Someone in my comments told me to dump molasses on my soil to supercharge my microbes. Someone else told me to spread coffee grounds everywhere to acidify my beds. And a third person, bless their heart, told me their landscape fabric has been down for 6 years and is working great. Look, I love this community, I genuinely do, but we need to talk. I'm Sunny from Sunnyside Soil. Today we're debunking 5 pieces of soil advice that sound totally reasonable, get repeated constantly, and are at best doing nothing for you. And at worst, they're actively working against the living system that you're trying to build. Let's get into it. Myth number 1, molasses feeds your soil microbes. The idea here is simple. Molasses is full of sugar, microbes eat sugar, so pour molasses on your soil and watch the biology explode, right? Well, not quite. Your soil microbial community isn't built on simple sugars. It's built on complex carbon, decomposing plant matter, fungal networks, root exudates. When you dump a large, easily digestible carbon source like molasses into the system, you trigger what soil scientists call the priming effect. A 2000 review by Kuzyakov and colleagues in soil biology and biochemistry described this in detail. A rapid influx of simple carbon doesn't feed your whole microbial community equally. It selectively feeds fast-growing, opportunistic bacteria, the R strategists, which outcompete the slower-growing fungi and bacteria responsible for long-term soil structure and nutrient cycling. You get a microbial bloom, then a crash. Researchers consistently document a rapid spike in CO2 respiration, meaning that microbes are burning through that sugar fast, followed by a population collapse back to baseline or even below. And if your soil has any drainage issues at all, that sugar load can push already borderline aerobic zones into anaerobic conditions, suppressing the exact organisms that you're trying to help. So what actually works? Complex carbon, compost, aged wood chips, cover crop residue. These feed a stable, diverse microbial community over months and seasons, not just until Tuesday. Myth number 2, coffee grounds acidify your soil. This one is everywhere. Coffee is acidic, grounds come from coffee, therefore grounds acidify your soil. That's the logic, and honestly, it's not crazy logic, it's just wrong. Here's what people are missing. Brewed coffee is acidic, with a pH typically around 5 to 6, but the grounds left behind after brewing? Well, most of the acidic compounds, chlorogenic acid and others, have already been extracted into your cup. Multiple studies, including work reviewed by Washington State University Extension, have measured the pH of used coffee grounds and found them to be nearly neutral, typically ranging from 6.5 to 6.8. Even if grounds were acidic, soil has something called buffering capacity, its ability to resist pH change. Unless you're adding grounds in truly massive quantities to a soil with very little buffering capacity, the pH effect would be negligible anyway. A 2016 study in urban agriculture and regional food systems found that coffee ground additions had no significant effect on soil pH across multiple application rates. But here's the part that actually concerns me. Fresh coffee grounds applied in thick layers can mat together, creating a hydrophobic crust that repels water and restricts airflow. They also contain caffeine, which has demonstrated allelopathic effects, meaning it can suppress seed germination and plant growth. Thin applications mixed into compost, that's great. Spreading them as a thick mulch around your plants, you may be doing more harm than good. So if you want to acidify your soil, test it first and use elemental sulfur based on what the test results actually tell you. Myth number 3, watering daily keeps plants happy. Now, I think that this one comes from a place of real care. You want your plants to thrive, so you water them every single day. How could that be bad? Well, ask a soil microbiologist and they'll tell you why. Healthy soil is roughly 50% solid material and 50% pore space. And ideally, that pore space is about half air and half water. Those air-filled pores, they're not empty. They're highways for oxygen, and oxygen is the lifeblood of aerobic soil biology. We're talking the bacteria, the fungi, the protozoa, and nematodes. Those drive nutrient cycling and plant health. When you water daily, especially in any soil that isn't extremely fast draining, you're consistently pushing water into those pore spaces and displacing the oxygen. Soil that stays consistently saturated becomes dominated by anaerobic bacteria, which produce byproducts toxic to plant roots. We're talking things like hydrogen sulfide, methane, and organic acids. A 2008 study in Plant and Soil documented significant root mortality and microbial community shifts in plants that were watered to maintain continuous saturation versus plants that were allowed to partially dry between waterings. What you actually want is what irrigation scientists call deficit irrigation, letting the top portion of the root zone dry out between watering events. This encourages deeper root growth, maintains aerobic conditions, and trains your plants to be drought resilient. Stick your finger about 2 inches into the soil. If it's still moist, then just wait a little bit. Your plants will tell you when they're thirsty long before they're in any danger. Myth number 4, Epsom salt fixes everything. If there's one gardening product that has been more aggressively over-marketed than its science can support, it's Epsom salt. Yellowing leaves, Epsom salt. Tomatoes not setting fruit, Epsom salt. Sad-looking pepper plants, someone in your Facebook group will tell you Epsom salt. And here's what the research actually says. Epsom salt is magnesium sulfate. Now, magnesium is a real plant nutrient. It's the central atom in the chlorophyll molecule, which is why magnesium deficiency does cause yellowing between leaf veins. Sulfur is also a real nutrient, so in theory, Epsom salt addresses real needs. The problem is that magnesium deficiency is actually relatively uncommon in most soils, particularly soils with any meaningful organic matter content. A comprehensive review by Chalker Scott at Washington State University examined the peer review literature and found no reliable evidence that Epsom salt improves plant growth, fruit set, or disease resistance in soils that aren't already magnesium deficient. And worse, excess magnesium competes with calcium and potassium for uptake at the root level. A 2004 study in the Journal of Plant Nutrition found that excessive magnesium applications suppressed potassium uptake and reduced yield in tomatoes. Exactly the crop that Epsom salt is most commonly recommended for. Here's a principle that I keep coming back to. You cannot manage what you haven't measured. So get a soil test. They're relatively cheap and sometimes even free through your county extension office. If your magnesium is actually low, then yes, address it. But spraying Epsom salt on a hunch is just as likely to cause a problem as it is to solve one. Myth number 5, landscape fabric is a permanent weed solution. Okay, last one, and this might be the myth that I feel most strongly about because it doesn't just fail to work, it actively destroys the soil ecosystem underneath it, often permanently. Landscape fabric. The gardening industry sells it as a long-term weed barrier. Set it and forget it. And for the first season, maybe 2, it kind of works. And then things go terribly wrong. Here's what happens over time. Organic matter, decomposing leaves, mulch, dust, they all accumulate on top of the fabric. Weed seeds land in that layer and germinate. Their roots grow down through the fabric weave and anchor in. Now you have weeds that are harder to pull than if there had been no fabric at all. But the soil biology damage, that is a bigger story. A 2019 study in applied soil ecology found that soils under landscape fabric showed significantly reduced earthworm populations, lower microbial biomass, and decreased soil respiration, even after relatively short installation periods. The fabric restricts gas exchange, limits water infiltration, and blocks the surface to soil organic matter pathway that feeds the entire soil food web. And here's the part that really frustrates me. Once you've had landscape fabric down for several years, the soil underneath is often so degraded, compacted, depleted, biologically dead, that you're essentially starting from scratch when you remove it. So then what actually works for long-time weed suppression? Deep organic mulch, 3 to 4 inches of wood chips, straw, or leaf mold. It suppresses weeds almost as effectively in year 1, and unlike fabric, it feeds your soil biology, improves moisture retention, and breaks down into organic matter over time. The work it does compounds. Landscape fabric's effectiveness only declines. All right, look, every single one of these myths exists because someone was trying to do right by their garden. Nobody pours molasses on their soil out of malice. Nobody buys landscape fabric hoping to wreck their earthworms. These are good faith attempts to grow better plants. But the gap between good intentions and good outcomes in soil health is always the same thing. Not understanding that soil is a living system with its own logic. Once you get that, once you understand that you're managing biology, not just chemistry, the right moves become a lot more obvious. You stop reaching for shortcuts that undermine the system, and you start asking, what does this system actually need to thrive? That's the question that I want this channel to help you answer. All the studies I referenced today are linked in the description. And if there's a piece of soil advice that you've always wondered about, something that you've heard that doesn't quite add up, then we have created a community where like-minded individuals like yourself can go and learn about soil health, vermicomposting, and compost. I'll leave a link in the description below for that community. I'm Sunny from Sunnyside Soil. Thanks for watching.